What's up, everyone? Today, I'm going to be doing two problems in LeetCode: the Fibonacci number and the nth Tribonacci number. Both of these follow suit with dynamic programming concepts that are very important. So if you like the content you watch, please do comment and feel free to subscribe if you feel like this content is useful. Let's start. Fibonacci number. The Fibonacci number is commonly denoted f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, f of 0 is 0, and f of 1 is 1. And f of n, any f of n, is just f of n minus 1 plus f of n minus 2 for n greater than 1. Given n, calculate f of n. Perfect. So, obviously, there is a solution that all of us could think of. That being, for n, we make a recursive call to return the Fibonacci number of n minus 1 and n minus 2. We go return. We call the same function again on n minus 1 plus fib of n minus 2, where we basically define a base case saying if n equals 0, then we want to return 0. If n equals 1, return 1. Right? So typed up, that is an incredibly straightforward solution for return. If n equals 0, return 0. If n equals 1, return 1. And then return Fibonacci of n minus 1 plus Fibonacci of n minus 2. How do I call myself again? Self.fib. How you make a recursive call. But you see how it was loading, just that solution alone, and how my runtime only beats like 20.3% of all users? This is because I didn't use a proper dynamic programming solution to solve this problem. Now, how would I approach this through dynamic programming? Dynamic programming, in a nutshell, is using memory of steps we've already done to help aid us in future calculations. Suppose we have up until f of 4 calculated and we need f of 5, right? We can just use that knowledge. And to find f of 4, we need f of 3. And assuming f of 3 is already calculated, we can use that in its calculation to find f of 4, thereby eliminating a bunch of steps where we're doing the same thing over and over again and we don't really have to. So, dynamic programming solution, I would first define an f of 0 to be 0, f of 1 to be 1. And once we have f of 0 and f of 1 defined, we simply call a for in range 2 to n, and we say fill up the f of n, or let's say for I in range, fill up the f of I to be f of I minus 1 plus f of I minus 2. And once we have our whole Fibonacci array instantiated, filled with numbers, we just return f of n. And effectively with this, we're eliminating steps we're making it more efficient by using the previous knowledge that we have about the Fibonacci sum to generate new numbers of Fibonacci without repeating the same steps that we did, calculating f of 3 2 different times, calculating f of 2 2 different times, Now we can instantiate an array f just to be, let's keep it temporarily, fill it up with zeros for now, times n plus 1. Because we want to return the nth number, and this is, the first element would be f of 0. We could say f of 0 is now 0, f of 1 is now 1, and for I in range 2 to n, f of I is simply f of I minus 1 plus f of I minus 2. We can now go ahead and return f of n. Here it should go until n plus 1. And perfect. We have a working Fibonacci solution that beats 88%, 89% of solutions simply by using this simple technique that capitalizes on memory that, or information that we already know, right? Let's get an nth Tribonacci number. Very similar problem, except now Tribonacci sequences use t of n plus 1, and t of n plus 2 to find t of n plus 3. Given n, return the value of t of n. Perfect. Similar concept. If we say if n less than or equal to 1, right? We can't say 2 in this case because t of 2 is equal to 1. Return n. To instantiate an array to be 0 times the len. Nope. Let's just do n plus 1. Keep it simple. And let's go ahead and instantiate f of 0 to be 0, f of 1 to be equal to 1, f of 2 to be equal to 1. Very similarly, we can go for I in range now from 3 to n plus 1. F of n equals f of n minus 1. Small mistake here. It's meant to be I instead of n. Sweet. That solves our problem. Perfect. Hopefully this was a helpful dynamic programming video that taught a few interesting concepts of how and where we use memoization, as they call it. But thank you guys for watching. Please make sure to leave a comment, like on the video, and subscribe. And I'll see you on the next one. Peace.